So in our next upcoming lab, we're going to be doing a synthesis. What we're going to be doing is we're going to be synthesizing an alum. Okay, so let's talk real quick about what synthesis is. Synthesis is basically a term that we use when we have a multi-step reaction mechanism, and we use that to produce or synthesize a specific product. Okay, and so the specific product we're going to be synthesizing is an alum. Now, when we talk about synthesis, we usually talk about maybe two key terms, and that is the quantity that we get, which is related to something we're going to call percent yield, and then also the quality of what we have, which we're going to use the melting point to identify that. Okay, so if we talk about quantity, we usually talk about percent yield. Okay, and we've seen percent yield before, right? It is our actual yield divided by our theoretical yield, and then we're going to go ahead and make that a percentage. Now, when we do that, when we're talking about our actual, okay, that is the mass that we actually weigh out, right? We do our reaction, we do our mechanism, and we see how much we actually produce. Our theoretical yield is calculated from our limiting reactant. So we look at our limiting reactant and we say if it completely reacts, well, how much should we theoretically get, right? And that tells us this quantity of our percent yield. Then we can also talk about the quality of our product. Okay, and the quality, what we're going to do is we're going to look at the melting point. Okay, and so we know we're trying to synthesize a specific product, this alum, and we can compare the melting point of what it should be to what it actually is. Okay, and so the closer to the actual melting point is going to tell us how close we are or how more pure the product we have. Okay, so we have these two things that we can use to kind of identify how much of a product we get, how well did we do our synthesis getting to the amount, and then we can also look at, well, if we have a good percent yield, do we actually have a quality product? Are we actually getting mostly alum that's left over in our product at the end? Okay, so now when we do this synthesis, we're going to be looking at these two things. We're going to look at our melting point, how well we get to that, and then the quantity that we have. Now, one specific technique we're going to use today is filtration. Okay, so in this lab, we're going to use two types of filtration. We're going to have gravity filtration, and we're also going to have vacuum filtration. Now, when we do this, there's two different ways that we kind of think through this. When we do gravity filtration, we usually have a funnel that runs into a beaker, and what we do is we pour into that funnel with the filter our liquid. Okay, so we have maybe our beaker here, and we go ahead and we pour that in. Now, out will come the liquid that comes through. A couple things we can identify here. The liquid left over that goes through our funnel, that's called our filtrate. Okay, so that's the liquid that goes through, and that's what we have at the end. Okay, when we're doing vacuum filtration, what we do is we have our Buckner funnel, okay, and then that runs into kind of our flask here. Okay, and then we have this vacuum flask that runs to our vacuum line, and we're going to again kind of pull our liquid through. Instead of allowing gravity to pull it through, we're going to pour into here our liquid. Okay, and in this instance, what we're going to see is we are going to still get our filtrate to come through. Now, there's two reasons why we would use maybe a gravity filtration versus a vacuum filtration. Gravity filtration is really good if we're looking at the filtrate. We care about the filtrate, what goes through. That's what we're going to use in our next step. Vacuum filtration is really good if we're looking at kind of these crystals or some kind of solid left over, and we can use our vacuum filtration to focus on that solid. Okay, so when we use these two techniques, gravity filtration is usually focused on us utilizing our liquid that's left over at the end, kind of separating the solids that we don't care about. Vacuum filtration is really helpful when we're trying to focus on drying out maybe a crystal or separating crystal or a solid from a liquid. And we usually have a small amount of liquid that we're going to pull through. And that way we can really get a good solid left over. The crystals are able to dry very well. And that's when we use vacuum filtration. Okay, so as we see, we're going to work through a synthesis this week. When we do that, we're going to focus on these two kind of values or identifiers of how well we did the synthesis. And then we're also going to use these two techniques of gravity filtration and vacuum filtration coming up in this lab. Okay, so I hope you have a great lab and experience synthesizing this alum, and you're able to get good quantity and also good quality from this.